Welcome back from lunch. We hope you enjoyed it, networking with friends and colleagues across the industry. Now we are ready to initiate the first section here after lunch, and we have Korak and Taniya presenting to you pre-ADSL, Revolutionise your ADaM workflow. And Korak is an associate director for statistical programming working at AstraZeneca. He's based in Cambridge, UK, and he's working in the late phase oncology space. Over the past 15 years, he has supported biopharma, oncology, and rare disease clinical trials across early and late phase portfolios. And he has been involved in and led multiple drug submissions around the world. Taniya is a senior statistical programmer at AstraZeneca with over 6.5 years experience. She works in the late respiratory and immunology therapeutic area and is currently based in Warsaw, in Poland. She has also worked in the late oncology and vaccines and therapeutic areas. So, great to see so many here. And Taniya and Korak, please give it away.
So, hello everyone. Am I audible?
Yes.
Yeah. So, hello to this good afternoon session, and I'm very happy to see a house full. So, let's kickstart our after lunch session with pre-ADSL that can revolutionize your ADaM workflow, and we will be presenting to you about 2 case studies so that you can understand better. This is today's workflow, and this is what we will be talking about. So first, we will be talking about the challenge, that how if we have a complex derivations that needs to be present in one ADaM and an ADSL in some form. So how do we deal with it? We have come up with a potential solution that is to create an intermediate data set, and we are consolidating all the similar derived values in an intermediate data set. We will provide to you about 2 real-life examples, and then we will talk a bit about CRT package and specifications, followed by the alternatives, of course. So, a typical ADaM workflow. So, we know in a clinical trial, when we create ADaMs, the first and foremost data set which we generally create is ADSL. Now, ADSL, it contains, of course, demographic information, but alongside it contains few important variables that can be used for subsequent ADaMs and to create variables that are needed for our clinical trial endpoints. So, for example, treatment arm, treatment started, treatment ended, and so on. These are the variables that is needed to create variables for other ADaM datasets. For example, the on-treatment flag and the baseline and post-baseline flag. So we need these variables, and for that, we need as an input variable treatment start date and treatment end date coming from ADSL. Now, let's think for a moment. This is the general static ADaM workflow. But what if we have complex derivations that we need in ADaM, and also we need to follow the same programming logic and present the variables in ADSL as well in some kind of form. So what do we do? Instead of following the same rederivation, let's think that we break the entire ADaM workflow and we create the data sets into pieces. After we create it into pieces, we merge everything together just like a Lego set. So, pre-ADSL. Pre-ADSL is one of this broken data set that we are creating and we are using it as our intermediate data set. So, pre-ADSL is an ADaM, other class data set, and it contains variables which are very simple, based on simple derivation. That is, either we take these variables directly from SDTM, we directly map them, or we just rename them. Or, for example, we just do some simple derivation just in case of age grouping. So if you see, from SDTM DM, we are taking U sub j, age, country, and yes, these are the part of pre-ADSL. From SDTM-EX, we are taking the treatment start date, treatment end date, and from the disposition, we are taking the randomization date, and so on. Now, this is our first case study, and we will go deep into pre-ADSL. And for that, I will hand it over to Korak.
Thanks, Taniya. This is working. So to look at the two examples we have, we first start with pre-ADSL. This is the example where we're using only one intermediate data set. And this is a situation where we are doing something called as an IDMC. Now, many of you know about what IDMCs are. These are independent data review committee meetings that we run during usually blinded or sponsor-blinded trials, where an external group of people are reviewing your study data to decide if the study should go on, if it's safe, etc., etc. Now, due to the blinded nature of these IDMC meetings, what usually ends up happening is you have an open session with members of the independent committee, along with some members of the clinical trial team who are blinded to the treatment regimen. And there, we look at outputs which are blinded in nature. Second, we look at a closed session where the same independent group of people are there. Along with them, you have unblinded members of the study team. For example, an unblinded statistician, it could be an unblinded clinician, and they are then looking at outputs where the treatment arms are open so everybody can see what's happening. Now, in this situation, in our study, we have two arms. One is an infusion treatment. The second is a tablet regimen. Because of this, the infusion regimen patients, they do need their body surface area to decide what the actual dose is. Now, because the vital sign information being collected in the two arms have a different collection visit schedule, the whole vital signs data set is blinded, so we can't see whose vital signs are where. But we do need the PSA information. Similarly, because of the two different kinds of dosing that we have, the tablets have a different follow-up period, the infusions have a different follow-up period. So your adverse events also need to figure out that what is the follow-up period that you use when reporting these. So the solution that we came up with was to use a pre-ADSL dataset. Now, in the case of the pre-ADSL dataset, with the two sets of programmers, the blinded and the unblinded programmer, the blinded programmer creates the pre-ADSL dataset code. This dataset code, we are focusing on two things, which is the treatment start date and the treatment end date, and the body surface area information. In reality, this is about 10 different variables, so we're not going into all of that detail. So this code is able to generate the information about what the treatment start dates and end dates are for each patient, as well as the body surface area for each patient. This code is then handed over to the unblinded programmer because operationally, unblinded programmers are not supposed to do a lot of coding, so they are just running the codes. They run the code, they create a pre-ADSL dataset on their end, send it over to the blinded programmer. Now the blinded programmer has all the information that they need, but they are not unblinded because they don't know who's got what. Subsequently, all the steps of creating the ADSL on both sides happen, creating the TFLs on both sides happen, and then as a critical check, you're comparing the total columns on both sides to make sure that you have reported the same sort of follow-up information, you have the same number of patients, etc., etc. So in this situation, the pre-ADSL is then operationally simplifying the way that you can still create the outputs that you want for the IDMC meeting. You're not creating dummy data, and it's taking away some complexity of follow-up of those data sets. So let's look at the second example now, which is slightly more complicated from Taniya.
Thank you, Korak. So this example, we will talk about, yes, Korak explained about pre-ADSL, but we will be talking more about pre-ADaMs and cross dataset. So cross is an intermediate dataset, and we will have a look further. So what is the problem statement? Why are we using so many broken datasets? We are using them because in terms of complex derivation, where we need to derive that particular variable, maybe let's say from a BDS structure, we need the param, that's the event of interest, and we need it as a grouping variable in ADSL. So if we see, the logic is same. And in terms of that, we are rederiving the same variable twice. So to avoid that, we are creating pre-ADaMs and cross dataset. We do have two potential solutions, but it has its own problem. The first one is from SDTM, we are creating ADSL, with all the complex variables that is needed. And from ADSL, we are creating the ADaMs, and again in ADaMs, we are deriving the same complex derivation. The problem, as explained, that we are deriving the same variables twice. The second one, it comes with, we are deriving an ADSL, a very simple ADSL, minus all the complex variables. Then we derive the ADaMs, and from the ADaMs, we are deriving the final ADSL, which now contains all the complex variables after merging with the ADaMs. And from here, we merge and form the final ADaMs. What's the problem here? The problem is recursion. ADSL gets created twice here, ADaM is getting created twice here. So what's our solution? Our solution might look like a recursion, but it's actually not. I will talk a bit more about it, but before that, in our study, we will be talking more about two data sets mainly here, that is ADMH, that's medical history, and ADQS. So in ADMH, we are taking the time since rupture dilation. Since it's a respiratory study, so we need to take the event for time since rupture dilation. From there, we are creating an ADSCRI dataset, that is an internal AstraZeneca BDS structured dataset that helps in the respiratory analysis. Now, we have the parameter in ADSCRI as time since rupture dilation, and we need this parameter in our ADSL as our first grouping variable. Now coming to the second dataset, that is ADQS. So since it's a respiratory dataset, so we are dealing with DSQ form, that is Dysphagia Symptom Questionnaire form, and that is a patient measure outcome that measures the dysphagia of patient having eosinophilic esophagitis. That is, in simple terms, patient, how much they can able to intake solid food. Now, here in our ADQS, that is ADQS, we are taking this DSQ form. This DSQ form has 4 questions, and after answering all the questions by the patient, the more the score is, the more is the severe is the dysphagia of the patient. Now, we need the baseline measurement of this score on over a period of 14 days. And after we get the baseline score of this, we need this baseline measurement score in our ADSL as our second grouping variable that can be used as a covariate for our efficacy analysis. So as you can see that for our grouping variables, we need a rederivation using the same programming logic. So we came up with a solution that might look like a recursion. It's not. We have a champion data set here, that is CROSS. So CROSS acts as a central programming logic repository that stores variables or that derives variables which needs to be created twice. If we look here, we have our pre-ADSL that is coming from SDTM. From SDTM MH, as mentioned, we are creating a pre-ADMH. From pre-ADMH, we are creating a pre-ADSCRI dataset that is an internal BDS AstraZeneca standard dataset. From here, we need the param-CD and AVAL. From the param-CD, we are taking the time since rupture dilation event, and from there, we are keeping it in CROSS. Now, deriving it as a variable in CROSS by transposing it. And thus, the first grouping variable is created in CROSS. In the second one, ADQS, we are taking the eval to take the baseline score of the patients with dysphagia. We take it and keep it in CROSS, transpose it, and our second grouping variable is ready. Now, with this CROSS, we merge the CROSS now with the pre-ADSL to create the final ADSL that now contains all the complex variables, that is the grouping 1, grouping 2, along with other pre-ADSL variables. And the CROSS is now merged with pre-ADSCRI or pre-ADMH to create the final ADaMs. Similar is the case for pre-ADQS, that after merging with CROSS, with the help of the common variables, ADQS, the final one, is created. Now, how does the specification looks like in our study? So, generally speaking, we create this specification on the basis of color coding. That is, if you see the ones coded in green are the variables that is coming from SDTMs. The ones that is the grouping variables that we are storing in the cross, those are color coded in orange, and the blue ones are coming from ADaMs. The CRT package, so in terms of dataset submission, we submit the final datasets and not the intermediate datasets. Of course, we have some alternative approaches to this, and I will be handing over to Korak again.
Alright, so you heard both of our case studies. Alternative approaches really quickly, and this you might have already seen, you might have already done. The very first one, recursion, we're just taking the example of the ADSL. You start with ADSL version 1, you create the new ADaMs, and as and when you have new information to add to ADSL, you keep adding it. As you can see here, you end up with version 4 of ADSL, but your ADaMs are still in version 1. This only works if you have a really good computing environment with version control. If you have one of the ones which are slightly problematic, then you can run into troubles, and we have seen plenty of them. The second is the standard approach of using a macro. However, the challenge with the macros is obviously the structure that the macro is outputting is different from a BDS structured data set compared to the ADSL, so the macro has to be able to handle all of that complexity. Other alternative approaches, and you will see a lot of references in our paper when you go online. These are all from there, and these have been around forever. ADSL core, where you have the basic ADSL, and you have AD base at the very end of the workflow, where you're capturing all the baseline information, so it can come at the very end, doesn't disrupt your workflow in any way. A lot of companies don't use AD base, but this is obviously an approach that's available. The second one is similar to what you have seen us doing, which is a lot of drafts and then a lot of finals. But this is also something that a lot of companies end up doing. Sometimes the drafts are in a different folder, the finals are in a different folder, so you can differentiate and not use the wrong ones. Bringing this to a close, I know we are running out of time as well. CDISC, not very recently, many years ago, came up with these two datasets, AD dates and AD events. If you work in oncology, you might have come across these. These originally were intermediate datasets. These are giving you more traceability. These are giving you options to look at your data better. And now CDISC says, well, you can submit these as submission datasets. So there is already a path for us to use similar datasets. The class is ADaM other. So you can always, as long as your datasets follow certain standards, you can use ADaM other class datasets. And AD core is another example where you have the core datasets and then the final ADSL. So ADSL is coming at the very end compared to the previous example where ADSL was first and AD base was at the end, so it's just flipping. So hopefully this has given you a good sense of how all of this can be done. I'm sure all of you are doing this in some form or the other. And I think we are done in time. So these are our references, quite a few of them. And these are all the people who helped, also a lot of them, with finding all this information. And that's it. So open for any questions. We are extremely sad that this is over. I'm extremely excited. I can do it next year, I hope. All right.
Thank you very much for the presentation. It appears as if you are creating all of your final ADaM data sets out of precursor ADaM data sets.
Yes, in that
You
example.
submit only the final ones. How are you dealing with the traceability aspect in documenting your
Do you want to
data
talk about it
flows?
first? Yeah, for the specifications, right. So, so the specifications that you saw, the color-coded specifications, the specifications only have the final data sets. So from the perspective of following your data flow, you're looking at a specification and a defined package which only talks about the final data sets. There's nothing else in there. In terms of the submission package, we are able to submit the codes for cross as well as all the other intermediate data sets along with the main submission package, and we give a note saying here are additional programs that we have used in the whole build-up.
Just to add up, those programs comes under ADaM other datasets. So I think it's compliant and we can send the entire package along with the pre-ADAMs.
Okay, so you submit the programs that create the precursor data sets, but you don't submit the precursor data sets.
Yes.
Okay.
We submit both the programs, so the main and the final
All
program.
right. And in the Define XML or the Data Reviewers Guide, do you,
You can
skip
explain.
you explain
You
that?
explain that there is an intermediate step.
Alright.
You have to run these programs in this fashion to get to it. I have had the submission experience of submitting only the pre-DSL in the past, and we did the same thing. So there was nothing in the submission document about the pre-DSL except that we explained that there was a data set involved in between. Here is the code for it.
Okay.
Yeah.
Thank you.
Hello, thank you. If you also experienced or looked for ADSAP, also ADSUB, this ADaM, what are you thinking of that, using that?
I can say I do not know that. Easy answer.
As you mentioned in the presentation, and as we know, traditionally we used to have the IDBase and all approaches already available. What made you think for still going for something new and going for this approach? What made you find it advantageous?
So the pre-ADSL example that you saw, that has nothing to do with the baseline data anyway. It was meant to solve an operational challenge of getting the right data in the ADSL flow, which is why nothing else sort of made sense. I guess with the AD base, AD core, etc., it sort of depends on where your company is in the stage of standards life cycle to say, okay, this is available and this is not available. So we are seeing AD core sort of moving around. Some projects maybe have tried AD base, but you can pick up any of the ways and go about it.
Yeah, honestly, it's not very popular. So that's why we came up with this pre-ADSL and pre-ADaM and the intermediate cross data set to make it as a repository for central programming logic.
Yeah, because I know only a handful of industry
Yeah.
leaders are using ADBase.
Yeah.
Then thank you very much for the